Hello and welcome back to Tovi. This session and tutorial will cover the U-star threshold detection. We can find this particular toolkit inside our toolbox menu. Here you can find the U-star threshold detection, which we'll click on to enter this tool. Now typically with eddy covariance measurements, as you're making them throughout the year, there's going to be quite a few times in which you're going to have insufficient turbulence in your measurements. You're going to have stable conditions, and primarily these occur during the nighttime. Now, if you keep these measurements inside your data, you're going to tend to create biases, and there's not really a correction for this for these kinds of conditions, but rather removing those points. So the idea here is to find the U-star threshold, which is also called the friction velocity, and determine a level at which the numbers above this threshold are considered valid flux measurements. Now, this is sort of an alternative to the micrometeorology tests that Foken does with the half-hour data, those flags that are provided in EddyPro as a 0, 1, 2. And so this tool is actually done on typically a seasonal basis, say over 3 months. And so you want to do this on a full year of data. If you try to do this on say for 3 months or a month of data, you could run into some issues. So the U-star threshold detection uses a moving point test to determine the value. And to learn more about this U-star threshold detection, if you remember in some of the other tutorials, down on the right we had an icon here that talks about the acknowledgments, the code, the publications for the particular tool that you're in. So here, for example, we have the paper that talks and discusses and does all the reviews of the U-star threshold detection. There's a list of authors that you can find here and see who was involved in working on that paper. This allows you to cite this particular tool in your papers as how you came to the value used for your U-star threshold detection. And we have some links provided by the names. Could be a way if you want to get in touch with any of the contributing authors to ask questions or anything like that. There's also some people's names we list here that have been involved in the code. For example, Alessio here, Dario Papale, also helping to design the code, provide scientific direction, and Carlo also providing a lot of advice to this particular code. So this U-star threshold detection method was developed by the Euroflex network. It was used in recent FluxNet data releases, and now is used by the ICOS and the Ameriflux networks. Okay, so let's go ahead and look at what we'll do in the tool here. We have our CO2 flux that we're going to use for determining the value. You have the option here to include the storage term for CO2. If you'd like to do that, simply check on the box. One thing you want to make sure as you go through and use this tool is typically you'll go through and use the QC screening tool first to clean up some of these variables like air temperature and shortwave radiation. If you have spikes or gaps in the data, then that could roll into the algorithm here and perhaps create some erroneous measurements and computations. So we're going to compute the U-star threshold. For the air temperature, we could use the one we've been collecting with the eddy covariance system, or you could choose to use one, for example, that came in with the biomet system that also was available inside the EddyPro file. Here, of course, we have the shortwave incoming radiation that's used as well. Now over here we have a couple settings, 3 settings that we use for doing a U-star threshold detection. Bootstrap. So bootstrapping is a statistical technique used to evaluate statistical estimates. And it's basically a process of resampling your sample, say, n number of times. 100 is the ICOS default, and you could increase this number to 200, 500, and typically you'll start to get some better results to some extent. but the time it takes to run the code might take a little bit longer. Down here we have temperature classes. And so you want to bin up your measurements in temperature classes because you're trying to determine and distinguish the difference where you have a slope in the relationship and where it begins to plateau. And when we run this algorithm, you'll see exactly what I'm talking about. And if you have a lot of data, you're able to do, for example, more temperature classes. But let's say, for example, you've done a lot of QC screening and eliminated a lot of temperature or had gaps in your data. You might not have enough temperature measurements to do 7 classes, and you might want to bring it down to 6 or 5 or something like that. The U-star classes then are the number of classes inside each of those temperature classes. This is used to help eliminate some of the noise that you're going to get using this algorithm. The default here number is set to 20, determined by ICOS. You can change this. And again, you might want to check out the paper that we talked about to see exactly how you might change this number and some of the reasons behind it. All right, so basically, there's not too many things to change here, and you can go ahead and when you're ready, click on the Start button, and it starts running that code. It'll take a minute here, and here we have our statistics. So we have some histograms, and again, as I mentioned, it's done per season. You have winter, spring, summer, and fall, and then your overall U-star threshold detection value. So for this particular data set that I ran for the year of 2013, at our field location, it's a 0.25. Now I can also come over here and look at the flux versus U-star. This is the graph I was talking about where you have a slope up to a certain U-star value, and then the values start to plateau. Now on this chart, if you look at this legend here, the color coding, for example, the brown color is for January, February, March, and then you have February, March, April, and so on. So these are 3-month intervals kind of overlapping each other. And this line here is the U-star threshold detection with some uncertainty shown by the gray band. Now I can go back and decide to change some of the settings by hitting that back button. And for example, I could come in here and say I want to do 8 temperature classes, and I simply then go back and hit the Start button. And I can go back and forth and reiterate and try to find out maybe which things are driving my values. You can see my U-star threshold detection is a little bit different than it was the previous time. And when you're finally ready and you want to apply that U-star threshold detection and wrap up this tool, then you simply go here and click on Done